Okay, so today we're going to talk about the memory model of Rust. Rust is a little bit different. If you've done stuff like Java, you know they have garbage collection. Generally in the C++ world, you have to keep track, especially C, you have to keep track of your memory yourself. Rust has an interesting way of doing it. And the first concept is that we're going to talk about is that of ownership. Um, Ownership means a value owns a owns the data, and if if it has a copy method implemented, it can copy it to another. It'll copy it to another variable, and it'll still be able to be used. However, things like strings do not have a copy. They so you if you say b equals to a, you can no longer use a. So let me find the example here. Here's a very simple example. We'll start with this. This is a very simple example here. I'm going to save this example too. We'll talk about that. Okay. So now I have to go get the first one. Okay. There we go. Let's copy it in here. All right. So you got yourself a string here, and you're going to set that string to a different variable. Now watch what happens. So you moved it. Instead of making a copy of it, you actually move the value. Now let's look at this example where you're not using a string, you're using a number. Now this is what that is. So you passed ownership, in this case of the string, from A to B, and A no longer owns it. So that's why when you tried to print it, couldn't print it. Gave you this error saying it's been moved. Now here's another one, but we're using a number this time. Notice it worked. Why? Because floats have a copy. So essentially you didn't give up ownership, you just made a copy, which is equivalent to, let's bring back the this example. Well, let's show you this example. This is the equivalent. So this is the way you work around. Instead of giving up ownership, you make a copy. So here we got our string. Now we clone it. We make a copy. But notice something. This is going to fail because here's another concept. It goes out of scope right here. So B no longer exists. Now, what we'll do, well, let's run it and you'll see that error. And you can see, that's interesting. Yeah, cannot find B in this scope. So it doesn't like that. However, if we take this, whoop, and we stick it here, watch now, and you can see it works because it's still in scope. So you can see the difference between classes that have a copy and classes that do not. If the class has a copy, then you would act like most languages, and it'll simply, if you set b equals to a, then it'll simply make a copy of a. If it does not, you have to work around that by using a clone. And note also, and we also talked about scope. So these brackets say B is only alive, only exists in this scope. So there you have the concept of borrowing, which is in the case where when you set B equals to, so we have B equals to, so this is the concept of ownership. And when you give up ownership versus making a copy, when you don't give up ownership. Now, the next concept we want to discuss is borrowing. Borrowing is essentially using a reference. So let's look at this. Let me see if I have a simple example. So here's a very simple example. Copy that. Now in this case, we have A, and B and C are borrowing A. They're not taking ownership of it. They're pointing to it. So maybe you could say it's a different name for reference, which is really all it is. The main difference we've seen so far, and the scope thing is also pretty much in every language. If you define a variable within the brackets or whatever they use to delineate scope, it could be, how much you indent. It could be brackets. It could be whatever. But if you define something in that, that's where it lives. And if you try to access it else outside of that, it will say, I don't know what you're talking about. The other concept with that is, let's say you define a variable outside scope, and then you define it again within a scope. It will assume it's within the scope generally, and we can try to demonstrate that here. But here we're borrowing. So when you run it, of course it worked. Now, let me do that scope thing again. So here's a scope. Let's see if we can show you what I was just talking about. Copy. I'm going to paste it in here, but I'm going to make, this is a local test. So we run this, and it did print it out. It did work as we would expect it, but it did warn you. It said that A is unused. So we can actually do something like this. Let's try that. Now you'll see it. You see exactly how you'd expect. This is the scope outside the brackets here, and when you print it, this is what it knows. It doesn't know this one anymore because these are local. And this one overrides the outside scope. Now, if you got rid of this and ran it, you see it doesn't override it. So that's essentially how this stuff works. Now, what was the next thing? This was about borrowing, where also you can see we could copy sorry, we're pointing to a reference rather than not making a rather than passing it to the other thing and losing it or cloning it, which is essentially a copy. Now, the other thing I want to talk about is mutability. Okay, let me show you an example here. Where did that example go? Here we go. Think. Oh. Here we go. I want to, here's it. Now notice I have, I'll show you this. Okay. All right. So here we got the main function. It defines the this printout, and it's going to pass it to input, and this is going to pass, and this should work, but this one won't because it's already passed, given up ownership. So this is a different example of what we've been talking about. Yeah, you can see. But where is the one? I had one where I added, let's see if I can find it. Here. Here's the example of mutability. So let's look at this one. Okay, so we have again a string that's defined as mutable, which means you can change it. We set C equals to that, which means, again, we're giving up control here. And B is a clone of C. We added to C, and then we print C. So let's look at that. Notice here, so it's mutable. Now, what they point out is the rules are very simple. And I'm just going to stick them here as a comment. Let's see if I can copy and paste it so you can read it here. Paste. All right, one or more. You can have one or more immutable references, one more immutable references, or exactly one mutable reference. So, as we saw before, we were able to pass it to several not mutable and not changeable variable. We were able to pass it to let several different variables access it or borrow it. Now, mutable, you can only have one. So if I turned around and did this, make this and made this E, this is going to fail for this reason. So let's run this. Second mutable borrow. So, unused. The second mutable, so here's your first mutable borrow. And then you tried, now I believe, because remember, exactly one mutable reference. And so even if we get rid of this C, we should still get an error because it is, let's see if I'm right. Yeah, more than, you cannot bar A as mutable more than one at a time. So exactly what the rule says. So let me see if there's anything we didn't cover. So we covered borrowing, which is essentially a reference. We covered ownership, which means if it does not have a copy method implemented, then you if you set it to another variable, it has given up ownership, and that ownership, so you can't use it anymore. Which that seems to me the big difference here. And in that case, you can either use a reference or you can make a clone. Actually tell it make a copy. So the other thing we talked about here is the two rules about references: one or more immutable references, or exactly one mutable reference. And I'm trying to see if there's anything we didn't that needs to be that we have not looked at. Oh, the other thing we learned is the final thing is went over the concept of lifetime. So if it's in the brackets, it's alive. If it's not in the brackets, once you get out of the brackets that it's defined in, it goes away. And I just want to check something here. Let's see. Yeah. So when it goes out of scope, as we were saying, the disappears, and we demonstrated that as well. So hopefully this has been helpful to kind of explain the way Rust handles memory, which has some differences, slight differences than Java or C++. Obviously, the way they do this, you can't turn around and it limits. The whole purpose is you don't want memory just getting lost. Java solves a problem with garbage collection. They solve it by being very strict and about where things are alive, exist or not exist, and you can't make infinite. If it doesn't have a copy implemented, a copy method, you can't make a copy of it. If you set it to something else, that's where it is now. And if you think about it, the strings don't have a copy method, but numbers do. Interesting. So anyway, again, hopefully this has been helpful, and thank you for watching, and I will speak to you next time. Take care.